There are 5 cars on sale, 2 BMWs, one of which has a sunroof, 3 Mercedes, 2 of which have a sunroof. I bought a car with a sunroof. What's the probability that it was a BMW? By the wording of the question, we can see that it is a conditional probability problem. The condition being that I bought a car with a sunroof and you're trying to find the probability of me buying a BMW. And you would set it up just like I did in the rectangle over there where it says find probability BMW given it has a sunroof. Now that we have recognized the problem as a conditional probability, we can apply the conditional probability formula, which you should have memorized. I already have the formula written here, and it reads like this. Probability of A given B equals probability of A intersect B over the probability of B. The third part, you can see here, that's where I've written where it represents the number of elements in each specific part of the probabilities. I did that so it'd be easier for you to identify each specific part of the problem. Once you get this down, and you may already, you'll just skip that and there will be no need to write that out. So now let's go through and replace A and B with BMW and sunroof. As you can see, I've already done that. Now we can just start plugging in the specific values to solve the problem. It's usually easier to start finding the denominator, which is probability of sunroof. So we'll go down here. First, we need to identify the number of elements in the sample space, as listed over here. And that's obviously 5, given in the first line of the problem. There are 5 cars on sale. So we'll just go ahead and write in a 5 there. Now we need to find the number of elements in sunroof. Well, that's just the number of cars that have a sunroof. Well, there's 2 BMWs, one has a sunroof, so that's 1. There are 3 Mercedes, 2 of which have a sunroof, so that's 2. And in total, that's 3 cars with a sunroof. Write that right there. That is the probability of sunroof right there, 3/5. So now we can go up and find the number of elements in the sample space again. That's the same, 5 cars. Now we need to find the number of BMW intersect sunroof. So how many BMWs have a sunroof? Well, there's just 1. So I'll put 1 there. Then we can simply go through, cancel out the 5s, and that will give us 1/3, which is the answer. Probability of that I buy a BMW given that it has a sunroof. As an additional note, I would like to go back a few steps to the top part of the equation here, where I have written number of BMW intersect sunroof. For some reason, a lot of students want to multiply these two, but that's just not what you're supposed to do. You're supposed to do just what I did. You identify the number of cars that are BMW and have a sunroof, which was 1. And that's going to be 1/5 because there's 5 cars total. So just to elaborate on that a little, I'll show you this here. So that multiplication where people are getting confused, that's only used for independent events. And that's where the probability of A intersect B equals probability of A times the probability of B. That means that the probability of A given B is just equal to probability of A. In other words, when you tack on the additional given statement, the probability of A does not change. So for a specific example, we have probability of A equals probability of BMW, probability of B equals probability of sunroof. In plain English, you could test for conditional probability by asking this: what is the probability of selecting a BMW given it has a sunroof, and test for independence, and does the fact that we must now choose one with a sunroof affect the probability of choosing a BMW? Clearly, the answer is yes, because there are only 2 BMWs to choose from. If you you're eliminating one because it doesn't have a sunroof, so that's changing the probability of selecting one with a BMW. So if you answered yes, like in this problem, they are not independent events. And this formula down here, probability of A intersect B, will not be equal to probability of A times probability of B. If the answer is no, they are independent. And an example of that would be, say, if the 2 BMWs both had a sunroof, and it tells you what's the probability of you picking a BMW given it has a sunroof. Well, it doesn't matter because they both have a sunroof, so it's not really affecting anything. So they'd be independent. A good rule of thumb is to disregard this formula unless the problem is either asking you to determine whether or not 2 events are independent, or it tells you the two events are independent.